Have you ever wondered how electronic circuits work? Well, buckle up because we're about to dive into the fascinating world of electronics. Electronic circuits are the backbone of modern technology. They're in our phones, our cars, our kitchen appliances, and so much more. In essence, an electronic circuit is a path or a network through which electric current flows. It's a system that's made up of various components like resistors, capacitors, and transistors, each playing a unique role in controlling and manipulating that electric current. Resistors, for instance, slow down the current, while capacitors store and release it. Transistors, on the other hand, act like switches, controlling the flow of the electricity. Just like the vocabulary of a language, these components are the building blocks of all electronic circuits. As we delve deeper into this subject, remember that understanding electronic circuits is like learning a new language. It opens up a whole new world of possibilities. Picture this. An electronic circuit is like a city's roadmap. It's a complex network of paths, each one leading to a different destination, and each destination a different component. This is where a circuit diagram comes into play. It's the blueprint of our electronic city, a roadmap that guides us through the intricate maze of electrical components that come together to form a functioning circuit. So, what exactly is a circuit diagram? Well, in the simplest terms, it's a visual representation of an electronic circuit. It uses standardized symbols to represent different components and shows how they're connected to each other. Think of it as a language, a universal code that electronics enthusiasts around the world understand and use to communicate their ideas and designs. Now let's dive a little deeper. Every symbol in a circuit diagram is a signpost that represents a specific component. For instance, a simple line often represents a wire or conductor, a path for electricity to flow. A zigzag line? That's a resistor, a component that resists or reduces the flow of electricity. A pair of parallel lines? You've got yourself a capacitor, a component that stores electrical energy. And what about a circle with three legs? That's a transistor, the building block of modern electronics. But a circuit diagram is more than just a collection of symbols. It's a story of connections, a narrative of how electricity flows from one component to another. These connections are represented by lines linking different symbols together, forming a path for the electric current to follow. In essence, understanding a circuit diagram is like learning a new language. It might seem daunting at first, but with practice, you'll start recognizing the symbols, understanding the connections, and before you know it, you'll be reading and creating your own circuit diagrams. So remember, next time you're looking at a circuit diagram, don't just see a bunch of lines and symbols. See a roadmap, a guide, a story. A circuit diagram is your guide, your treasure map to creating a working electronic circuit. Before you begin your journey, you need the right tools. It's like setting off on an adventure, isn't it? Just as you wouldn't go hiking without a map and a compass, you wouldn't dive into building an electronic circuit without the right gear. Let's start with the breadboard. This is your canvas, where you'll create your masterpiece. Next, you'll need jumper wires. Think of them as your paintbrush, connecting your components together. Speaking of components, you'll need resistors and capacitors. These are the building blocks of your circuit, controlling the flow of electricity. Don't forget the transistor, the heart of the circuit, amplifying or switching electronic signals and electrical power. And of course, none of this would work without a power source. You could say this is the lifeblood of your project, powering your electronic circuit. So there you have it, your toolkit, a breadboard, jumper wires, resistors, capacitors, a transistor, and a power source. Armed with the right tools and materials, you're ready to start building your electronic circuit. Now it's time to bring your circuit diagram to life. Let's dive into the heart of the process. Building your electronic circuit. We've got our tools, we've got our materials, and we've got our circuit diagram. Now we're ready to start assembling. Our first step is to place our components on the breadboard. This might seem straightforward, but it's crucial to get it right. Remember, each hole in the breadboard is a potential connection point, so make sure to place your components in the correct spot according to your circuit diagram. Now let's talk about resistors. These little guys are crucial to controlling the flow of electricity in your circuit, so it's essential to place them correctly. When you're inserting them into the breadboard, ensure the metal leads go into the holes, while the colored bands, which indicate the resistance value, stay visible. Capacitors are up next. These components store and release electrical energy, and they come in two types, polarized and non-polarized. Polarized capacitors have a positive and a negative lead, so be sure to plug them in the right way. Non-polarized capacitors, on the other hand, can go in either way, moving on to LEDs or light-emitting diodes. These components emit light when an electric current passes through them. They're also polarized, with a longer lead for the positive side and a shorter one for the negative. So pay attention to which way you're plugging them in. The next step is to connect all these components using jumper wires. These wires will carry electricity from one part of your circuit to another. Make sure to use the right length of wire for each connection and ensure each wire is securely inserted into the breadboard. Securing your connections is vital. A loose connection could lead to a component not working or worse, the entire circuit failing. So don't rush this step. Take your time to ensure each component is securely connected. Finally, it's time to connect your power source. This could be a battery or a power supply unit. Regardless, make sure to connect the positive terminal to the positive side of your circuit and the negative terminal to the negative side. Building an electronic circuit isn't just about connecting components. It's about understanding the flow of electricity and how each component interacts with the others. It's about patience, precision, and problem solving. It's about turning a simple diagram into a functioning piece of technology. Remember to always double-check your work. Make sure each component is in its correct place and every connection is secure. And most importantly, don't be discouraged if things don't work perfectly the first time. Troubleshooting is a key part of the process, and every mistake is a learning opportunity. And there you have it, your electronic circuit is now ready for testing. The moment of truth has arrived. It's time to test your circuit. Now, testing a circuit isn't just about flipping a switch and hoping for the best. It involves a careful and methodical approach, ensuring that live tests are conducted safely and effectively. Let's walk through this process real quick. To start, we need to connect our circuit to a power source, but remember, safety first. Before you plug anything in, make sure you're using the correct voltage. Too much power can fry your circuit, while too little won't give you the results you're after. Once you've verified your power source, go ahead and connect it to your circuit. If all goes well, your circuit will come to life, and that's when you'll know you've done everything right. But what does a successful test look like? Well, it depends on the type of circuit you've built. If you've made a light circuit, for example, the light should come on. If it's a sound circuit, you should hear a sound. It's as simple as that. Now, if your circuit doesn't work as expected, don't panic. Troubleshooting is a big part of the learning process. Start by checking your connections. Make sure everything is plugged in where it should be and that there are no loose wires. Next, double-check your components. Are they all in good condition? Is anything overheating or showing signs of wear and tear? If so, replace the faulty part and try again. If you're still facing issues, it's time to revisit your circuit diagram. Compare it with your actual circuit and see if there are any discrepancies. A small error in the layout can cause the whole circuit to malfunction. Remember, patience is key. Building and testing circuits is a process of trial and error. It might take a few attempts to get it right, but that's okay. Each mistake is a learning opportunity. With a successful test, you've just built your very first electronic circuit. Now, wasn't that a rewarding experience? Keep experimenting, keep learning, and most importantly, keep having fun with electronics. The world of circuitry is vast and fascinating, and you've just taken your first step into it. Congratulations. You've embarked on an exciting journey today. We started off by diving into the fascinating world of electronic circuits, understanding the language they speak through circuit diagrams. This gave us the blueprint to navigate the electronic landscape. We then moved on to gathering our tools and materials. We made sure to get everything we needed, from resistors and capacitors to our soldering iron, ensuring we were well prepared for the task ahead. Next, we rolled up our sleeves and got down to business, building our very own circuit. We followed our diagram, connecting the dots, so to speak, piece by piece, until we had a fully assembled circuit right in front of us. Finally, we tested our creation, ensuring everything was working as it should. The satisfaction of seeing our circuit come to life was truly unmatched. Remember, every expert was once a beginner. Keep exploring, keep learning, and who knows, you might just be the next big thing in electronics.